Hello, good evening, my dear students. Welcome to Gradeup, India's biggest e-learning platform. This is Sooraj Gopi. I welcome you all to this very important class of radiation network. Quickly join the session and please do let me know whether I'm audible and you're able to hear the voice and see this video in a very clear manner. So, very good evening, all of you. Good evening, good evening. So this is a series which is very helpful if you're preparing for GATE 2021. Okay, so you will be having a complete revision of the heat transfer subject. Good evening guys, good evening Krupa, good evening Mani, good evening Vasudev, Aritra, good evening. So how are you all? Perfect? All good? How is your preparation going on for GATE 2020? I hope so all of you are now revising. It's like almost we are at the end of November, so we're having December, Jan, and we can say Feb. So almost 2 months is left for GATE 2021. You just need to put the accelerator pedal and you need to boost up your preparation with the grade up by giving the different mock tests, by attending the live sessions like this. Everything okay? Very good evening, Vivek, good evening, Vasu. Fine. So today we'll be talking about the radiation network. Okay, we'll be basically talking about radiation network. And if I say from the heat transfer perspective, radiation is a very easy topic. Okay, two topics important yet easy is heat exchanger and radiation network. Okay, so we'll be discussing each and everything, and also we'll be solving some problems, important problems that will improvise your understanding on this particular topic. Okay, so everything is fine. So let's shall we start? I hope so. All of you are gate or will be writing gate 2021, and it's very important. You just one tip I would like to share with you is please do attempt the mock test. Okay, do attempt the mock test whenever you are getting any chance, and always go for the practice. Go do more practice because now only the practice will be making your concept clarity. Okay, let's start the session. Let me introduce myself. My name is Sooraj Gopi. I have more than 5 years of teaching experience. Mentored 15,000 plus aspirants for GATE, EAC, and SSCGE. I am expertise in mechanics, thermal applied, heat transfer, industrial, and theory of machines. Okay, now. Now, if I talk about radiation gate perspective, there are three topics which you need to study. If I say radiation, if I broadly, if I classify, one is your shape factor. They are asking question directly from the shape factor. Okay. Second important topic is your radiation network. Okay, radiation network. Under radiation network, you'll be having like the calculation of heat exchange, heat exchange calculation, heat exchange calculations, and the second question they will be asking from the radiation network is the radiation shield. Radiation shield. Okay, and the third is your loss of radiation. Loss of radiation. Loss of radiation. Under loss of radiation, if I say precisely, which is most important, your Stephen Boltzmann is important, your Wade's displacement is important. Planck's, you only have to understand the basic concept, that's it. And the Lambert cosine is also an important loss of radiation. Okay, so these three topics are very important. So we'll be today we'll be talking about shape factor and radiation effect. These are the most important and yet most scoring topic from the radiation. Okay, so let's start from the first, that is your shape factor. What is a shape factor? Anyone who can help me out, what is a shape factor? What is a shape factor? Sir, it's very easy. If I talk about shape factor, it's a very easy topic. Shape factor basically means the amount of radiation which is leaving a surface 1 and reaching surface 2. If I say, let us suppose I'm having two surfaces, this is surface 1 and this is surface 2. So fraction of radiation which is leaving surface 1 and reaching surface 2, that we call it as a shape factor between 1 and 2. Under the shape factor, two theorems you have to remember. That one is your reciprocity theorem, reciprocity theorem, and second one is your summation rule. Second one is your summation rule. Okay, these two theorems are very effective and very important. If I talk about reciprocity theorem, it is being applied between two surfaces. That means if I say F12 is a shape factor from surface 1 to 2 into the area A1 is equal to the shape factor from 2 to 1 into the area A2. Very important. This is only being applicable between the two surfaces. But if I talk about summation rule is basically being applied on the multiple surfaces. Let us suppose I'm having n surfaces. So we can directly say F11 plus F12 plus F13 till your F1n will be equal to 1. Okay. So these two rules, these two theorems you have to apply whenever you are dealing with any question coming from the shape factor. Okay. So shape factor very easy. It accounts the fact that entire radiation leaving surface may not completely reach its other surface as electromagnetic waves travel in a straight line. Okay, so definitely it is not mandatory. If I say from my left hand, there is 10 units of radiation being emitted from my left hand, it is not mandatory that all the 10 radiation will be reaching my right hand. Okay, there is a possibility like only 90% is reaching, so that 0.9 will be calling it as a shape factor from 1 to 2. Clear? Fine, easy. So shall we solve some problem shape factor, then we'll be going with your radiation network and we'll be solving some question from that topic. First question, let's see how many of you able to solve this very easy question. For the circular tube of equal length and diameter as shown in the figure, the view factor F13 is 0.17. The view factor F12 in this case will be easy question, directly apply the summation rule and tell me the answer. Okay, yes, quickly, what will be the answer for this question? There is a circular tube and we are having three surfaces. This is surface 1, this is surface 2 and this is surface 3. Okay, so F13 is given, F12 you have to calculate what is. Now we can use summation rule, we can say F11 plus F12 plus F13 is equal to 1. Okay, so can anyone tell me, yes, can anyone tell me what will be the value of F11? Very good, very good. Correct, Mukil. Vivekananda, very good. Absolutely correct. Okay, so F11, first surface 1 is a flat surface and we know that from a flat surface, the shape factor from its own surface will always be equal to 0 because it's a flat surface. Okay, very good, Krupa. So this is 0. F12 is you have to calculate and F13 is 0.17 equal to 1. We can directly say F12 is equal to 0.83. 0.83. Easy question. Easy question. 0.83. Let's try to increase the difficulty level and tell me what will be the answer for this. We are having a solid cylinder which I am classifying it as surface 2, which is located at the center of a hollow sphere. We are having a hollow sphere. Okay, at the center we are having a solid cylinder which is classifying it as surface 2 and this is your surface 1. The diameter of the sphere, that means let us say the diameter of the sphere is 1 meter and the diameter of the cylinder small d is equal to 0.5 meter and L is equal to 0.5 meter. So you have to tell me what will be the shape factor from 1, 1, that means from surface 1 to its own surface, what will be the shape factor? F11, very easy question. What will be the value of F11? Is it equal to 1? Yes or no, sir? No, it won't be equal to 1 because definitely some portion will be hitting surface 2 and some portion will be hitting its own surface. Okay, so you have to tell me what will be the value of F11. So we know that F21 is equal to 1 because from the surface 2 it's a cylindrical surface and we are talking about the outer cylindrical surface. So definitely from all the three sides 1, 2 and 3, all the three sides your radiation will be happening and that will be equal to 1. So from this I can get the value of F12 by reciprocity theorem. F12 will be equal to F21 into A2 by A1. Okay, now what is F12? This is equal to 1. A2, what will be this area A2? Anyone? What is the surface area of a cylinder? Now in this case we'll be taking all the three sides because if you observe closely, if this is your cylinder, you can have radiation from this surface, you can have radiation from this surface, you can have radiation from this surface, all the three surface. Okay, So let me write this as small r is equal to 0.5 by 2. Capital R is equal to 0.5 meter. I can write it like this, where capital R is the radius of the sphere and small r is the radius of the cylinder. Now let's apply your F12 is equal to 1 into A2. A2 is the area of the cylinder, that is uh, 2 pi r square plus 2 pi r into L, okay, divided by the area A1. What is the area of a sphere, hollow sphere? It is, yes, what is the area of sphere? This one. It will be 4 pi capital R square. 4 pi capital R square, and also we can say capital R is equal to twice small r, and also capital R is equal to L, so that our calculation becomes very easy. So this is your, we can say 2 will be cancelling out, pi will be cancelling out, so r square plus r into L by 2 into capital R square. Instead of capital R, I can write 2r, small 2r. So let us write this is r square plus 2r square upon, this will be 8 small r square. So this is 3 by 8. So I got the value of F12 is equal to 3 by 8. But we have to calculate F11. So F11 plus F12 is equal to 1. So F11 is equal to 1 minus 3 by 8, which is equal to 5 by 8. Your final answer will be, very good, 0.625. Always remember, shape factor can never ever exceed more than 1. Okay? Shape factor can never ever have a value greater than 1. Is this clear? Shape factor, if I say the range of shape factor, if I talk any surface Mn, it is always greater than 0 and less than, it is always greater than equal to 0 and less than equal to 1. Okay, very good. Option B is the correct answer. Option B is the correct answer. No calculators required. Quickly you will be getting the answer. Shape factor, they are frequently asking. This is a favorite topic. If any question you are expecting in the gate, if they're asking from the radiation topic, definitely you can expect this type of question in your gate examination for 2 marks. These are all 2 marks problem. Okay, fine. Let's proceed for the next question. I hope so. Abhi, Vasudev, Vivekanand, Abhi, Krishnan, Krupa, clear? Any doubt in this? Okay, let's proceed for the next question. Next question. Consider two infinitely long, thin concentric tubes of circular cross section. We are having tubes, okay. We are having surface 1 and surface 2. These are two concentric cylinders like this, having diameter d1 and d2. Okay, inner diameter is d1, outer diameter is d2. You have to tell me what will be the shape factor F22. Quickly, I need quick response from all of you. What will be the value of F22? Abhi, Krupa, Vasudev, quickly respond. Aritra, Manikandan, Vivek, what will be the answer? And please, all of you, please do respond along with me, because that will be very helpful for you guys only. Because unless and until you are not discussing, it won't be having a better clarity. Any doubt, do ask me in this live session. Okay, so let's proceed for the solution. We know that F12 will be equal to 1, because all the radiation which is leaving surface 1 has to reach surface 2. Okay, very good, Bibikanand, correct answer. So F21 will be equal to F12 into A1 by A2. Very good. I'm getting mix of answers. Imran Khan is saying 0. Okay. It won't be 0, because definitely if I say this point, definitely it will be having radiation in all the directions, so it will be hitting its own surface. So definitely B is not the answer. Very good. So what will be this? This is your cylinder. The area will be pi d into L, the surface area. So this is 1, this is pi d1 into L divided by pi d2 into L. So this is d1 by d2, but we have to calculate F22, this is F21. So F22 will be equal to 1 minus F21. So this is 1 minus D1 by D2. The correct answer is all of you are correct. Shivam, Mukil, Manikandan, Abhi, Vasudev, Krupa, Purushottam. Option A is not correct. You have taken the reverse of that. Okay, that is not correct. Lalita, hello, hello. Option D is the correct answer. Okay, option D is the correct answer. Very good. Next question. Let's see who will be responding to this question in the first, who will be quickly responding and accurately. Quickly tell me. Let's see which student will be solving this question quickly and correctly. There is a solid sphere which is taken as surface 1 of radius r, and we are having a hemisphere of surface 2 of radius 4r. What will be the shape factor F21? What will be the shape factor F21? Anyone? I need quick response and correct also. Let's see who will be responding it quickly. Shivam, Lalita, Mani, Abhi, Vasudev, Krupa, Purushottam, Swarupa, Kishore, quickly. So we have first response from Vivekanand. Okay, he is saying 1 by 2. Anyone else with your answers? Okay, so we're having Krupa also with B. Fine, I need quick response. All of you quickly respond. What will be the correct answer? Okay. Okay, very good. Look, it's very easy. We are having this as surface 1 and this is surface 2. So we have to calculate F2 to 1. We know that F12 is equal to 1. So F21 will be equal to F12 into A1 by A2. Okay, we are getting some response as A also. So this is 1 into what is A1? What will be the area of this is solid sphere? Solid sphere is 4 pi r square. 4 pi r square. What is A2? This is hemisphere. Hemisphere is having a surface area of 2 pi r square. But in this case, our radius is 4r. We can directly add 2 pi into 4r whole square. So this is 4 pi r square by 2 pi into 16 r square. Now tell me what is the correct answer? What is the correct answer? R and r square get cancelled. This get cancelled. This is 4. 1 by 8. 1 by 8. F21. 1 by 8. Where did you committed mistake? It is equal to 1 by 8. Very good, Abhi. Correct answer. How we are getting option A? So the first correct answer was given by Abhi Krishnan. Very good. The first correct answer was given by Abhi Krishnan. Absolutely correct. Mukil, Krupa, Manikandan and Shivam. Make sure you are not committing the mistake in the exam. I hope so you have seen what was the problem. You have taken the wrong area, I suppose. Okay, 1 by 8 you are getting. Krupa, very good. Option D is the correct answer. Let's see now who will be responding quickly. Next question. Let's see which candidate will be responding this previous year IES problem of 2009. What will be the view factor 2 to 1 for this geometry? We are having a sphere at the center and a cube. The side of the cube is D and that is also the diameter of the cube, the sphere. Let's see who will be responding quickly. I want quick response. And I'll be announcing his name right now in this live session. I need correct answer. Let's see who will be that student. It's a previous year IES. Those who have solved previous year IES question, they will definitely be responding quickly. We are having a sphere at the center surrounded by a cube. Is it option A pi by 2? Is it option B pi by 4? Is it option C pi by 3? Or is it option D pi by 6? Very easy. You have to calculate F21. This is surface 1. This is surface 2. Okay. Very good, Dharani Krishna. Dharani Krishna has responded. Dharani Krishna has responded. Very good. I need more response. Anyone supporting Dharani, please respond, or else you can give your answer. Abhi also correct. So we are having Dharani and Abhi Krishnan. Both of you are correct. Very good. Pi by 6 is the correct answer. Option D. It's very easy. We are having F2 to 1. F1 2 will be equal to 1. Same concept again and repeat it again and again. So F21 will be equal to F12 into A1 by A2. Very good. Very good. Krupa, Kishore, Vivekanan. This is 1. What is area 1? This is your 4 pi into r square. I can write it as pi d square. The surface area of a sphere is pi d square divided by the surface area of a cube, 6 into the side is d. So this is nothing but pi by 6. Hardly it will take 10 seconds. I will be taking 5 seconds. You should be taking to answer this type of problem. Option D. Very good. Vishal. Correct. Next question, let's see. Now, before going for the next question, let's try to understand the radiation network. What do you mean by radiation network? And then we'll be solving some question from this radiation network. Now, what is this radiation network? In radiation, we are having two resistance. Very important. We are having two resistance in radiation. Okay. Now, in radiation, we are having a surface resistance. Resistance, and second is your space resistance. I'm not going with the derivation, I'm directly coming with the result. Now what is surface resistance? It is basically equal to 1 minus emissivity upon emissivity into A. And what is space resistance? That is 1 upon A1 into F2. Basically, what is the meaning of this? Whenever we are talking about any surface, all the surface will be having some surface resistance except the black body. Okay, and if you're talking about between two surface, if it is kept with some distance, definitely it will be having some space resistance. Okay, so let me tell you, very important. Let us suppose we are having, let us say we are having two parallel plates, which is kept at temperature T1 and second at temperature T2. Okay, this is emissivity 1 and this is emissivity 2. So can you tell me how many resistance are there between these two parallel plates? Now, those who don't know, it will be very easy to understand. If I say on this surface will be having one surface resistance, between these two plates will be having one space resistance, and on this surface will be having your surface resistance too. Okay, so in total we are having three resistance, out of which two are surface and one is space. Okay, let me ask you one question. Okay, very good. Let me ask you one question. Let us suppose I'm having, let me remove this. Let us suppose I'm having two plates. Okay, and this is a black surface, and this is also a black surface. Now tell me how many resistance will be there in total. Can anyone tell me? This is temperature T1, this is temperature T2. Can anyone tell me how many resistance will be there between these two plates? Total resistance. We know that in radiation there are two types of resistance, surface resistance and your space resistance. Now tell me what will be the surface resistance at surface 1. What will be the surface resistance at the surface 1? Sir, we know that for a black body emissivity is equal to 1. Emissivity is equal to 1 and this surface emissivity is equal to 1. So we'll be having only one resistance, that will be your space resistance. Why? Because we know that surface resistance is equal to 1 minus emissivity upon emissivity into A, and if I say emissivity is equal to 1, this will be equal to 0. So we are only left out with only one resistance, that is your space resistance. Very good, absolutely correct. Those who are able to respond this question, definitely they are having the clarity of this topic of radiation network. Very good, absolutely correct. Okay, fine. Is this clear? So what we can say, we can now draw the circuit diagram. From this. Let us suppose this is two parallel plates having emissivity E1 and E2, temperature T1 and T2, we are having three resistance, that is 1 minus emissivity 1 into emissivity A. This is your space and this is your surface. Surface, space and surface. So what I can say, if I want to write the heat exchange between 1 and 2, I can write EB1 minus EB2, Ohm's law, electrical analogy, 1 minus emissivity 1 upon emissivity 1 A1 plus 1 upon A1 F12 plus 1 minus emissivity 2 upon emissivity 2 A2. Okay, so this is a standard formula. No, if you're talking any surface, let us suppose instead of plates, if you're having concentric cylinders, instead of concentric cylinder, if you're having concentric spheres, no problem. This is your generalized equation. You can only change will be having is in the areas, but the general perception, general approach in radiation is quite easy. So it makes radiation topics the most easiest topic in your heat transfer topic. Okay, in your heat transfer subject, radiation is the most easiest. So let me take this example. Okay, so this is your total heat transfer between 1 and 2. This is your space radiation, this is your surface radiation, surface radiation, space radiation, and again a surface radiation. Okay, is this clear? And we know that EB is equal to sigma T1 to the power 4. Let me see if I say EB1 or EB2 is sigma T to the power 4, where sigma is the Stephen-Boltzmann's coefficient. The value of the sigma is 5.67 into 10 to the power minus 8. Okay, but let us suppose I'm talking about some special cases. Then some special cases, some special formula. No, my dear friend, we won't be having any special formula. If I talk about parallel plates, same formula. You can observe on your screen. This is temperature T1, this is temperature T2, emissivity E1, emissivity E2, same formula. Let us talk about concentric cylinders. If I talk about concentric cylinders, again same formula. It is Q1 to 2. This, let us suppose this is 1, this is 2. This is equal to sigma T1 to the power 4 minus T to the power 4 upon, or instead of that, let me write in terms of the black body. Let me write in terms of black body, EB1 minus EB2 divided by 1 minus emissivity 1 upon emissivity 1 A1 plus 1 upon A1 F12 plus 1 minus emissivity 2 upon emissivity 2 into A2. Same formula again repeated. If I talk about concentric sphere, same formula. This is 1 and 2. So it doesn't matter what kind of surface you are talking about. The ultimate approach for getting the heat flux or heat transfer between surface 1 and surface 2 remains the same. Okay, that is this. Let's try to solve some question and see how much you have understood from this topic, and after that we'll be talking about the radiation shield and we'll be solving a question and we'll be concluding the session. Okay, the radiative heat transfer per unit area between plane parallel gray surfaces having emissivity 0.9 maintained at 400 Kelvin and 300 Kelvin respectively is, that means we are having two parallel plates, okay, which one surface is maintained at 400 Kelvin, second surface is maintained at 300 Kelvin, and both are gray surface. That means emissivity 1 is equal to 0.9 and emissivity 2 is also equal to 0.9. This is your T1, this is your T2. So tell me how many resistance will be there, 1, 2 or 3? Quickly respond. Vishal, Mani, Shivam, Vivekanand, Dharni, Krupa, Abhi, Shivam, Mayur, Mani. Quickly, how many resistance will be there between these two parallel plates? Very easy, logical question. Let's proceed by step. You need to approach for solving the question. So there will be 1 or 2 or 3. Quickly, sir, we will be having 3 resistance, 2 surface and 1 space. Okay, very good, very good. Abhi has already calculated this solution. Absolutely correct. We'll be having 3 resistance, okay. So direct formula, 1 to 2 sigma 400 power 4 minus 300 power 4 divided by 1 minus emissivity 1. We have to calculate in watt per meter square. You can take A1 is equal to A2 is equal to 1, A1 is equal to A2 is equal to 1 meter square, because we need to calculate the heat flux per unit area. So plus 1 by 1 plus 1 minus emissivity 2 upon emissivity 2. Okay, ultimately you will be getting, when I make more simplified form, it will be 400 power 4 minus 300 power 4 divided by twice of emissivity minus 1, because both the plates are having the same emissivity. When you solve it, you will be having the simplified form like this. Put the value, you will be getting 812 watt per meter square as the correct answer. 812 watt per meter square as your answer. I hope so this you are getting. 812 watt per meter square. Is this clear? 812, option B. Very good, Abhi. Abhi, Krupa, Mukil, Kishore, Mani and Shivam. All of you are correct. Very good, very good. Thank you for that quick response, Abhi. Very good. Krupa also, Mukil. It was like a fraction of seconds difference between these three students. Very good. Keep it up. You'll be getting 812 watt per meter square. Okay. Yes, very good, Kishore, Mani. Let's proceed for the next question. Let's see. Now let's see who will be responding it quickly. There's a hemispherical furnace of radius 1 meter. We are having a hemispherical furnace of radius 1 meter as inner emissivity is equal to 1. Its roof is maintained at 800 Kelvin, while the floor, that means, will be having a flat surface, which is your surface number 2, okay, which is kept at 600 Kelvin and whose emissivity, let us say E2, is equal to 0.5. So you have to tell me what is the net heat exchange between the two surfaces, that means between the roof to the floor. What is Q1 to 2? So now tell me, first of all, first question is how many resistance will be there? How many resistance will be there between 1 and 2? Between 1 and 2, how many resistance, total resistance? Can anyone respond to this problem? 1, 2 or 3? Sir, surface number 1 is a black body, so definitely we won't be having any surface resistance. Space resistance is always present. Surface 2 is a non-black body, so total resistance will be only 2. Okay, only 2 resistance will be there. One is the surface resistance at 2 and the space resistance between the two surfaces. Okay, now you can directly use the formula Q1 to 2 is equal to sigma T1 to the power 4 minus T to the power 4 divided by 0 plus 1 upon A1 F12 plus 1 minus emissivity 2 upon emissivity 2 into A2. Okay, now in this case you need to calculate the shape factor F12. We have already calculated this F12. I hope you all remember F12. What will be this F12? F21 is equal to 1, F12 will be equal to 0.5, so F12 will be equal to 0.5. You calculate, you'll be getting F21 is equal to 1, apply reciprocity theorem, you'll be getting F12 is equal to 0.5, put the value A1, what is the value of A1? Very good, very good. Very good, Kishore, correct. I need to check with the answer, Kishore. I think you are not correct. So we'll be having, if I'm having space here. So this is your Q1 to 2. This is sigma T1 power 4 minus T2 power 4 divided by what will be A1 area. A1 will be 2 pi r square. Now radius is 1. Radius is 1 meter. Radius is 1 meter. What will be A2? A2 will be pi r square. Okay, place this value and get the answer. Place this value and get the answer. This will be 1 upon A1 is your, where is A1 here? 2 pi r square. So it is 2 pi r square into 0.5 plus 1 minus emissivity 2 is 0.5 divide by 0.5 into A2. What is A2? A2 is pi r square. Pi into r square, and we know that r is equal to 1 meter already given. 0.5 into 2, 1. So this is, keep this as it is. Your calculation is very easy. This is 1 by pi plus 0.5 and 0.5 get cancelled. This is again 1 by pi. So your final answer Q1 to 2 is equal to pi into sigma into T1 is 800, 800 to the power 4 minus 600 to the power 4 divided by 2. This is your final answer. Solve it and tell me what is the, very good, Mani. Mani Kandan has responded correctly. Absolutely correct. you will be getting 24.937 kilowatt. Okay, little bit of a calculation, but this was a very important question from gate perspective. I hope so now you have understood this question. Very good. And please do hit a like. I'm seeing many of the students have still not liked the session. Give a like so that whenever we are coming live, you are getting similar pattern, because uh, every day now Gradeup will be having the classes for all the mechanical aspirants. Confused at F12, definitely I would rather say 60% of students have taken F12 as 1, which is not equal to 1. F12 is equal to 0.5. That is why I've taken up this problem, so that you commit the mistake, understand the mistake, and next time whenever you're solving this question, you won't be committing this mistake. Okay, the best rest part is very easy. Only tricky part is this F12. Some students have taken F12 as equal to 1, which is not correct. Okay, so your final answer is 24.937, 24.937 kilowatt. Very good. Shivam, very good, very good. Okay, is this clear? The key point is F12. Rest calculation is purely mathematical. Only you have to do is the calculation. The logic behind this taking up this problem was the shape factor concept. Next question. Okay, now let's talk about radiation shield. What is radiation shield? Now, radiation shield, if you see this person, now many of you might be seeing this kind of suits, because now Corona is also at its peak. You know that third wave is hit, like definitely be coming in India. So make sure all of you are staying safe at your home, and you are sanitizing your hand. These type of equipments you might have observed nowadays very frequently. Okay, so these are not same, but we are using this type of your clothes in the nuclear reactor, because this will reduces the radiation effect. This is, we call it as radiation shield. It is basically used to reduce the radiation effect. Okay, and it is very good. Chernobyl, many of you might have watched this series, Chernobyl, where we had like a nuclear blast happened, and many of the people still are suffering from the reaction from that. So in order to reduce that nuclear reactions, everyone who are basically undergoing who are doing the experiments in the nuclear power plants, they are wearing this kind of equipments or this kind of shield. We call it as the PPE. Okay, we call it in short form PPE. Okay, fine. So it is basically used to reduce the radiation effect, because what will happen, due to its high reflectivity, much of the radiation will be reflected, and the persons won't be affected by the radiation effects. So it is extensively being used in nuclear reactor. It is used to measure the temperature of flame or any combustion temperature, because high temperature, high radiation, if you are directly going to, if you are directly showing the skin, they will be having a reaction. Okay, that is why we are using this type of kits. We call it as PPE kits. Thin aluminum strips, due to its high reflectivity property and low emissivity, because we know that what is surface resistance, we already have seen your surface resistance is equal to 1 minus emissivity upon emissivity into A. If I use a shield of low emissivity, that means your surface resistance will be high. If the surface resistance is more, that means you will be having high blockage to the radiation effect. Okay, is this clear? So if I quickly tell you about the shield, yeah, let me write it over here. So shield is basically used to reduce the rate of heat transfer. Reduce the rate of heat transfer. Now shield is basically is nothing but a flat plate. Sheet is nothing but a flat plate. Let us suppose I'm using a single shield. So earlier, if I say without shield, number of resistance were 3. There were 3 resistance, two surface, and one space. Already we have seen, if we are having no shielding, in total we are having 3 resistance, and already we have seen this expression. Okay, and we have seen, okay fine, we are having this heat transfer between the two plates like this. But let us suppose if you're having some radiation shield, let us suppose I'm inserting a shield 3. Now tell me, can you tell me how many total resistance will be there? Total resistance will be there. And what will be the total surface resistance? Total surface resistance and total space resistance. Okay, or I can say how many surface resistance and how many space resistance. Anyone? Very easy concept. Space and surface resistance. We are having one shield of emissivity E3. Sir, we will be counting. Okay, sir, we'll be having here the surface 1, surface 2, surface 3, surface 4. We'll be having 4 surface, and between space, this is space 1, this is space 2, so we'll be having 2 space. So in total we'll be having 6 resistance. No need to count like this. I will be telling you the shortest method. Surface resistance is equal to 2n plus 2. Space resistance is equal to n plus 1, where n is the number of shield. Okay, fine. So by using this formula you can directly calculate the number of resistance. Fine, let me give you an example. Let us suppose I'm having let us say 1 2 3 4 shield, and these two are plates. So quickly tell me how many space and how many surface. How many space and how many surface resistance? Quickly, I need quick response. Let's see who will be giving at the first end about this problem. How many surface and how many space? And put a comma with this. If let us say we are saying 7 surface, so 7 comma 2. Okay, fine. 7 comma 2 given by bull shark. Nice name. Shivam is giving the previous one, right? So surface 2n plus 2. This is your surface. Space, this is your n plus 1. How many number of shield? 1 2 3 4. So this will be 10 and this will be 5. 10 and 5. Yes, I think Kishore has given first one correctly, but the second one, okay. Number of shield is 4. Number of shield is 4. 1 2 3 4, n plus 1, 10 and 5. I don't know why some of the students are giving 7 and 2. Total 15. This will be total. Okay, Krupa, is this clear? 10 and 5. 2n plus 2. 2n plus 2. Because these 4 are shield and these 2 are plates. These 2 are plates. Okay, let us count those who are having doubts or how this is having this much value. This is your surface 1, this is your surface 2, this is your surface 3, this is your surface 4, this is your surface 5, this is your surface 6, 7, 8, 9 and 10. 10 surface, and in between 1 space, 2 space, 3 space, 4 space and 5 space. Is this clear? Understood? Okay, endless signs. Thank you. Fine. Very good. Very good. Okay. Correct. So total 50. There is now let us compare these two factors. Initially we were having no shield, we were having 3 resistance. By inserting single shield, your resistance has increased from 3 to 6. That means your rate of heat transfer has been decreased. Okay, so that is the reason by shielding, by doing the shielding operation, we are effectively reducing the radiation heat transfer. Okay, so if I say what should be the property of a shield, yeah, definitely. Look, if you see this diagram, if I say without shield, we are having in total 3 resistance, that is your surface, space and surface. But if you go with shield, let us suppose I am using a single shield, I am now shifting from 3 resistance to 6 resistance, that is 4 surface and 2 space. What is the meaning of this? By introduction of single sheet, you are increasing the resistance to a higher value, and the rate of heat transfer between the plates has been tremendously decreased. Okay, that is why shielding is so important to reduce the radiation effect. That is why it is extensively used in the safety purpose. Okay, this concept is basically used in the safety purpose of the human being or any mankind. Okay, is this clear? Now the question is, what should be the property of a shield? Sir, I need to increase the resistance. So if I say the surface resistance, it is equal to 1 minus emissivity upon emissivity into A. If a surface is having low emissivity, okay sir, please stay slow because I want to note. Okay, fine. So if your emissivity is less, then your surface resistance will be high. If surface resistance is high, definitely we can say your heat transfer will be less. That is why we are taking less emissivity, and we know that your absorptivity is equal to emissivity and your reflectivity is equal to 1 minus absorptivity. That is the reason we always go for a highly reflective surface. Highly reflective surface, very important concept. This is coming from your Kirchhoff's law. Always always we go for a highly reflective surface, because if we are talking about highly reflective surface, the absorptivity will be less. If the absorptivity will be less, that means your emissivity is less. If emissivity is less, your surface resistance will be high, and if the surface resistance is high, your heat transfer will be less. Okay, yes, definitely, bull shark. Sir, I want to have a doubt in heat exchange between surface and surrounding. Okay, for a black body, resistance is 0, EB is equal to J, then what will be the value of Q? Sir, okay, fine. Let's take this doubt and let's see how much you have understood. So we are having a surface, and this surface is a black body. According to Sri Hari, this surface is a black body, and emissivity is equal to 1. So what will be the value of Q? Okay, so basically you are saying you want to calculate the heat transfer from the surface to the surrounding. This is your question. I suppose, from surface to surrounding. What should be the heat transfer if this is a black body? If this is a black body of emissivity 1, this is your T1 temperature. Fine. So what will be the heat transfer from surface to the surrounding? This is your question, right? Yes. Rest of you, could you please help me out in this? What will be the heat transfer from surface to the surrounding? Do we have any heat transfer? Yes or no? Let us suppose we are having some radiation which is incident. Tell me whether any of the incident will be reflected. Let's go step by step. This is a black body. Do we have any reflected portion of the incident radiation? Yes or no? Let's see who has understood this concept. A black surface, I is radiation which is hitting the black surface. Any reflection possible? Yes or no? Quickly. Do we have any reflection possible? Sir, we know that black body, very good, Mahmood, endless Abhi, alpha is equal to 1. Your reflectivity equal to 0. Reflectivity equal to 0 means no reflection. That means everything will be absorbed. But my dear friend, we know that from Stiefel-Boltzmann, any surface which is having 1 Kelvin also will be emitting radiation. So definitely from this surface will be having some emissions. We call it as black body emission. So we will be saying from surface to the surrounding, what will be your emission? It will be directly equal to EB, and that will be equal to sigma T1 to the power 4. Is this clear? And this is in watt per meter square. Per meter square we are answering. Okay, it won't be equal to 0 because every body having a unit Kelvin also will be having some emission. Okay, and this is a black body. Black body is having the highest emission. That means highest emission. There are two factors. One is emission and second is reflection. There are two different. Reflection depends upon the incident factor. Emission depends upon the absolute temperature of the body. Is this clear? Is this clear? Yes. Why? Nahi. No. Yes. Why? Because black body is having a property. It is a perfect absorber. It is a perfect absorber. It is an ideal emitter. It is an ideal emitter, and it is a diffusive surface. I hope so. Everyone knows the properties of a black body. It's a perfect absorber, that means reflectivity equal to 0. It's an ideal emitter, it will be having the maximum emission. That is why, if you have observed, if you go back to this, sir, I'm very exhausted, sir. Please wait. Okay, definitely. Is this clear? I'm going a little bit slow because radiation is a complete, if I say minimum, it requires 1 to 1.5 hours to complete. If I go with in much of detailing, but I'm not going in that much of detailing because this is a revision part. I hope so you know the basic concept. Only we are doing is doing this revision. Okay, no worries. Just clear up your concepts. Now, what is diffusive surface? Diffusive surface means, if I say this is a black body, if this is a black body, so definitely will be having emissions in all the direction, and that will be equal. That is I. This type of surface we call it as the diffusive surface. Yes, Sri Hari. Okay. Endless science. There's like 2 months left, so let's keep aside that rest portion. Let's do hard work and get the rank. After that, rest of the life. Exactly. Now, that is why I'm telling you this. If you see this, okay, let me give you one. Yeah, let me explain you over here. Let us suppose this is a black body. Denominator is not 0, my dear friend. If you observe, denominator is a non-zero, only numerator is 0, right? Numerator is 0. Is this clear? We are not calculating. Let us suppose this is a black body. Let us take that example, black body, and this is also a black body. Let us suppose both the cases. Okay, so in this case, this will be equal to 0, this will also be equal to 0, but you will be having a space resistance always coming into the picture. We'll be having, and if I draw the circuit diagram for this, we'll be having EB2. Is this clear? Is this clear? Yes. Understood? Is this clear? If I'm saying there are two black bodies, if there are two black bodies, okay, so definitely the surface resistance will be equal to 0. If they are equal to 0, we are only left out with the your space resistance. That's it. Clear? Okay. Yes, Akhil, what is your doubt? Definitely, if there is, let me explain one more time. If there is a non-black body, let us suppose we are having a non-black body, so definitely from this surface we'll be having a value of J. Okay, okay, we'll be having the value of J. This is your I. Definitely a portion will be reflected back like this, rho into I. So we'll be saying, sir, your total radiosity will be equal to rho into I plus your emission due to the temperature. Okay, but if this is a black body, let me draw this, compare this with over here. Let me go for a non-black body and a black body. Let us have a pure clarity. What is the doubt you are facing? This is a non-black body, and this is a black body. This is a black body. Okay, so we are having this is, we call it as irradiation. Ge, we call it as irradiation. Let us suppose same G is falling. Fine. Definitely is a non-black body, a portion will be reflected back. Let us suppose rho into g is the reflected portion, and due to the temperature it will be having some emission. Let us say this is equal to E. Same thing, let us suppose this is your temperature T. This is a black body, so definitely we can surely say that nothing will be reflected. No portion will be reflected because this is a black body and will be having emission due to the temperature. We say it as EB. Why EB? Because this is a black body. Okay. Now, what is your radiosity? Your radiosity will be equal to J. This is equal to rho into G plus E. This is for a non-black body. But if I call for a black body, your radiosity will be equal to only EB because no reflection part. Now it's clear. Now it's clear. So for a non-black body, if I want to draw, you won't be having any J. If I'm talking about for a black body, you won't be having any J because from the surface EB is going out, and that is will be your exactly. Only the reflected portion will be clear. I hope so. Akhil has clarified. Okay, Akhil and Bull Shark has clarified their doubt. Is this clear? Understood. Exactly, because definitely we know that from Stephen Boltzmann, if a body is having a temperature T, it will be having radiation. If that temperature is 1 Kelvin also, will be having some radiation, but that will be very, very negligible. Is this clear? Black body and a non-black body. Very easy question. I hope so. Now we have understood the logic behind this problem which you are facing difficult. Okay? Bull shark, is this clear? Done? So can we proceed? Yes or no? I hope so. We have understood. We have done a very detailed discussion, and many of the students have clarified their doubt because they were facing a doubt between reflection and emission. There are two terms. There are two terms. One is reflection, and second is emission. These are entirely different. Okay. Emission is basically happening due to the incident radiation. Incident radiation. And emission is basically happening to the temperature, that is your absolute temperature. Absolute temperature. I hope so. Now this is clear. Okay. Clear? Let's proceed. Now we were talking about one important formula about the radiation shield. We have discussed whenever using a shield, we are increasing the resistance and we are decreasing the rate of heat transfer. Okay. Now let's understand. Let us suppose I'm having two parallel plates. I'm having two parallel plates, and in between I'm using a shield. All are having the same emissivity. All are having the same emissivity. Now in this case there's a very short formula. Your Q with shield is equal to Q without shield divided by n plus 1. This is only applicable only if the plates and the shields are having the same emissivity. All are having the same emissivity. Then only we can say this formula you can use. Okay. Now let us suppose if I'm using one shield. If you're using one shield, that means n is equal to 1. You are able to reduce 50% of the heat transfer has been reduced by using a single shield. Let us suppose earlier it was having a heat flux of 10 units. Now the heat flux has been reduced to 5 units. Okay. So by using a single shield, exactly, this is only applicable. Please make sure this condition. This is only applicable if the plates, shield and the plate are having the same emissivity. Is this clear? Understood? This is a complete gist of radiation. Let's try to solve a question and let's see how many of you are able to understand. Two infinite parallel plates, and this question was asked for 2 marks from the previous year gate. Two infinite parallel plates are placed at a certain distance apart, and infinite radiation shield is inserted between the two plates. So basically we are having two plates, and in between we are inserting a shield. Okay. without touching any of the reduce heat exchange between the plates. Assume the emissivity of the plates and the radiation shields are equal. The difference, that the ratio of the net heat exchange between the plates with and without the shield will be equal to. Sir, once again explain diffusion. Definitely, let's try to answer. They are asking the ratio of with to without. Okay, now in this case all plates are having the same shield. Absolutely correct, Abhi. It will be equal to 1 by 2 because n is equal to 1. So 1 upon n plus 1 is equal to 1 by 2. That means 50% of the heat has been reduced by insertion of a shield. Okay, 1 by 2, my dear friend, because shield, number of shield, n is number of shield. Okay, n is number of shield. Very good, Mayank. Absolutely correct. Very good. Is this clear? Krupa, very good. Correct answer. Option A. Shivam Singh, very good. Option A. Now, Dharni, what was your doubt, sir? Explain diffusion one more time. Now, if I say black body, if I say a black body, if I say a black body, it is having three distinct properties. A perfect absorber, already we have seen this expression, and we have also already uh, seen this explanation. Ideal emitter, and the last one is a diffusive surface. What is a diffusive surface? Diffusive surface basically means, if I'm saying there is a point, and if I'm this is a black body, so we'll be having emissions equal in all the direction. That means intensity will be same, equal in all direction. Okay, this type of body we call it as the diffusive surface. Is this clear? Equal intensity in each direction. This kind of surface we call it as diffuse surface, and that is the property of a black body. Is this clear? Fine. Okay, so this basically completes your radiation topic in detail. Very important. We have taken only the gist of all the radiation. Okay, only left out topic is your loss of radiation, and that they are asking direct formula based, that is Wien's displacement, Stephen Boltzmann. Already we have taken Stephen Boltzmann in one radiation network. I hope so that is clear. Fine. So these are the three live courses on the Gradeup platform who are preparing for GATE and ESE. Okay. So we are having a gear up gate, a rank up gate, and vision 2021. So those who want to revise the entire syllabus of GATE, we are running a gear up gate mechanical course. Those who want to improve their GATE score, they can proceed for the rank up course. This is will be having practice session, 80% problems, 80% problems, and 20% your theory. Only this is best for the, very good, very good. This is best for the students who want to improve their rank in the gate, and this is for the second year and third year students, those who want to aim for ESE and gate in the year 2022. This is the best course, ideal for second and third year students. Any doubt, you can definitely call to this number, and our backend team will be surely helping you out. And these are the students who have secured ranks in top 100 by using the Gradeup platform. I hope so next year you all guys photographs will be pasted. Only you have to do is you need to subscribe to this Gradeup Super, get the live access, and one benefit is this: if you are subscribing to this Gradeup Super, you will be getting the access to all these courses. That is the best part. That means single solution. Okay. Fine. So thank you guys, and these are the cost for Gradeup is providing EMI option for the different students. So for 6 months 2000, 12 months 1400, and for 24 months we are having 1000 rupees per month. I hope so all of you have enjoyed this session, and make sure before leaving the session you all are you are giving a like. Do share this video and subscribe to this channel, so that whenever we are having any uh, video, you will be getting the notification and on the first hand. Okay, so thank you guys. Stay safe, stay connected. Bye bye, good night, and please stay safe, because that corona is increasing at a very quicker pace, so we need to stop that pace, and we need to collectively fight against this corona. So thank you guys. Bye bye, take care, good night, and stay safe. Bye bye guys.